So we have this geometric series that we are asked to solve, and it's going to say that, okay, find the sum of all values in the series of n equals 0 to infinity of 3 to the 2 plus n times 2 to the 1 minus 3n. And we're asked, what is the sum? Basically, we need to know if it converges to one number, and if we know that, we can find the sum. Okay, so how we go about doing this is we're going to say, okay, this 3 here, we can actually rewrite it. We can say that this is 3 to the second times 3 to the n. Notice how this is correct. We have like terms. When we multiply them together, we add the exponents. It's just another way to write it here. Pretty simple. So we have that, and then we're going to multiply it by the same thing with the 2 to the first times 2 to the negative 3n. All right, let's factor out our constant terms here. And there shouldn't be parentheses, but I did that anyways. Let's factor out our constant terms. 3 to the second, that's 9, times 2, that's 18. So we're going to say it's 18 times 3 to the n times, and we can actually go ahead and rewrite that 2 to the negative 3n as 1 over 2 to the negative 3. So this could be 1 over 2 to the 3n. Notice that we have a power here, and we're allowed to distribute that in. So we could say that this is actually 2 to the third. So that would simplify to 8 to the n. And one more simplification we can do, we can say it's 18 times 3 over n over 8 to the n. Okay, notice how this statement is true. You should begin to see our series here. We're going to have the 18 as our A. And if your professor gave you a different way to put this, I'll explain it, what each variable means in just a moment. But notice, if you have two exponents, top and bottom, you can pull it out and express it as a fraction to a power. So this will be 3 over 8 to the n. Okay, this is our r value. Notice that we're starting at 0. We want our first term to be whatever a is, alrighty? So, and there's something that you need to know about these series, and I hope that you'll be able to see this here. Notice how our thing here, our r value is less than 1. If r is less than 1, what happens as we go to infinity, right? Notice, so for here, our first n value, we get 3 over 8. We did it again, we get an even smaller value because it's a fraction times a fraction. For example, if we have 1/2 times 1/2, that gives you a lesser value of 1/4. That's the same thing that's happening here, right? Imagine this was 1/2 to the n, and I plugged in 10,000. Well, you're going to get a very, very, very small number, right? Basically 0 when you get to infinity. That's the exact same thing that's happening to here. It's decreasing every time we increase the n value. Hopefully that makes sense to you. But we're actually able to solve here. Hopefully you've seen the shortcut before, where we take, okay, we have the sums, and then we add up all the sums, and then we do that weird manipulation where we get a over 1 minus r as the sum of all of the values here. So we are able to do that. Remember, a is 18, and this is going to be 1 minus 3 over 8, which is our r value. Hopefully that makes sense to you. So let's go ahead and solve. Maybe it simplifies, but if not, well, we'll just have to suck it up, Buttercup, right? All right, this is going to simplify into 144 over 5. Now, we know that this value is always going to decrease, so it's going to converge to 0, or not to 0, to this value here because of this formula that we have. Alrighty, so I hope you guys enjoyed. If you did, please drop a like, subscribe, and comment if you have any questions, and I hope you have a wonderful day.